This is our multimeter. It takes readings from our spectrophotometer. Our spectrophotometer is shown over here. An LED diode on this side of the spectrophotometer is powered by a watch battery. We have a positive and negative end. So as you can see here, when the watch battery is inserted, a light comes on. That's our LED diode. A sensor on the opposing side of the spectrophotometer catches the light from the LED diode shining through a cuvette, which then threads through to the wires attached to our multimeter. Our multimeter is on the 2M setting. This is a relatively low setting since we aren't reading something of super high resistance, it's just algae. This is generally used for electrical work, which is why we're using a lower setting. Now that I've got the spectrophotometer booted up, I'm going to show you how I load in a blank. So we take our watch battery and attach the positive and negative ends accordingly. And then we take our cuvette and take the reflective end filled with 0.5 milliliters of just blank tap water. Then we go ahead and stick it into the spectrophotometer so the LED diode can shine through the liquid and take an electrical reading on the other side. As you can see, the blank reading for our cuvette is shown. As you can see, it's pretty darn close to zero. That's because water should technically have a resistance of zero. Obviously, our machinery is slightly fallible considering kind of the homemade nature of it, but this is a pretty good reading to get us started with reading our samples. Now that our blank has calibrated the machine, I've taken the blank cuvette out and I will load in 0.5 milliliter of dilute sample. This sample's been diluted by a 1:5 ratio, so there's 1 part sample in 4 parts tap water in order to dilute it. And our reading has ticked up all the way to 0.021. I then took that measurement and subtracted our blank measurement to standardize the data, then multiplied that standardized measurement by our dilution factor to get 0.06 ohms for this sample.